The discovery of gravitational waves in the system has shown that this prediction made by Einstein 107 years ago is true. The findings also resulted in a revolution in the world of astronomy. Join us today as we reveal scientists' findings on gravitational waves. But here is the main question: what gravitational waves actually are? According to space, Einstein proposed that violent cosmic events, such as two black holes colliding with each other, may lead to space-time ripples called gravitational waves. Such waves can be observed across several light years. If you also enjoyed this content, please don't forget to like and hit the subscribe button and the notification bell so you don't miss our next videos. The Space Academy reports that some gravitational waves could result from galactic mergers, such as SBMHs, supermassive black holes within the cores, or post-Big Bang occurrences. Such gravitational waves were reportedly first picked up by the LIGO, Laser Interferometer Gravitational Wave Observatory, in 2016. The Space Academy reports that ever since such a phenomenon was spotted, various gravitational waves have been seen to stem up from different areas, including neutron star or black hole mergers. With the advancement of technologies used for these gravitational waves, specialists could spot even more sightings and find out more about these gravitational waves. The Universe Today reports that, for one, a global astronomer team recently picked up various low-frequency gravitational waves through the IPTA, International Pulsar Timing Array. They determined that such waves could have been early signals of B gravitational waves, background gravitational wave signal, that resulted from supermassive black hole pairs. The existence of B gravitational waves has been theorized by astrophysicists ever since the discovery of the first gravitational waves. Scientists have also been on the lookout for GWBs, gravitational wave background, since such a phenomenon was first spotted. For instance, MSPs, millisecond pulsars, are used as galactic clock systems by the IPTA, International Pulsar Timing Array, EPTA, European Pulsar Timing Array, NANOGRAPH, North American Nanohertz Observatory for Gravitational Waves, and PPTA, Parkes Pulsar Timing Array. Neutron stars, on the other hand, move around 100 times per second. They also have great magnetic fields, with electromagnetic radiation concentrated around their poles. Such energy is released as pulsing radio waves. Because of their notable consistency in lengthening periods, such an effect has been used by astronomers to trace time. Their light flashes have also been used to gauge interstellar distances and examine the space in between the stars. Ever since the founding of GW astronomy, they have been looking for BGW signs. These research groups have recently mixed data sets, including that of the IPTA data release 2. It composes exact timing information from pulsars of 65 milliseconds. Analyses and further collaborations revealed that there is solid proof for a GW signal that has a low frequency. This is due to the different pulsars directed at it. Astrophysicists expect to observe similar findings in a gravitational wave background. Results did not just support GWB existence, which is something that has been rallied by astronomers for a long time. They also revealed the exemplary operations of instruments and observatories. Such results supported the thought that similar signals could be picked up across various data sets in different collaborations. However, though findings strengthen the case for GWB, scientific communities warn that they still do not have evidence that GWB is indeed occurring. The primary aim of examining gravitational waves is to find evidence that pulsar signal strength in various areas of the sky is linked in a particular way. These correlations have yet to be spotted, but the currently present signals align with their perceptions of what could happen. Moving forward, the IPTA will be examining more data to see if the signal indeed serves as evidence for GWB. More scientific groups will also be collecting further data in the coming years. But here is another fact that recent study reveals possibilities of detecting gravitational waves from extraterrestrial sources. The pursuit of finding confirmation of extraterrestrial intelligence continues. Now, thanks to recent research efforts, this may be answered with the help of gravitational waves. Science Alert notes how a new study was conducted by Applied Physics, a group of global engineers and scientists. They noted that detectors based on Earth, like the LIGO, Laser Interferometer Gravitational Wave Observatory, must theoretically be capable of picking up gravitational waves that result from extraterrestrial sources. According to the experts, this may expand the scope of search because specialists may go beyond and search through every star across the galaxy. So let's talk about the main difference between gravitational waves and electromagnetic waves. The existence or non-existence of life beyond Earth has been an object of focus as it is one of humanity's biggest questions. However, humanity's capacity to look for technological signals only covers some thousand stars. Science Alert also notes how the electromagnetic waves used by humans for communication tend to weaken or attenuate as they disperse. Because of this, it is quite impossible to rule out all the noises in the universe that go beyond some 100 light years. This is not the case, however, with gravitational waves. These waves do not weaken like electromagnetic ones. They can also be traced at farther distances. Hence, if an intelligent population exists out there with technology capable of releasing strong gravitational waves, humans can detect it. Such waves could be the only universe-probing tool that humanity can use that does not depend on light. Strong events create these waves. Futurism notes how the gravitational waves detected so far are thought to be clashes between neutron stars and black holes. Such strong occurrences expel great ripples across time and space. These ripples have been picked up by certain observatories, like the LIGO. But here is humans' biggest question. Could extraterrestrial life be traced through gravitational waves? The recent paper brings up the idea that extraterrestrial civilizations could create ripples that are similar through warp drives. These are hypothetical propulsion systems that enable spacecraft to travel near or even faster than light speed. This is because any mass can produce such effects if its acceleration is speedy enough. Even if there are uncertainties that come with this argument, scientists are optimistic about the potential. Applied Physics CEO Johnny Martiri expresses how their study on warp drives leaves the pathway for the detection of gravitational waves. Martiri also shares how the usual range of electromagnetic waves does not box the approach. Hence, with this, experts will be granted the capacity to probe through the many stars scattered around the galaxy to trace warp drives. He further adds that the ability to probe through several other galaxies will soon be possible. Futurism notes, however, that before commencing the search for these forces, the world's technology must catch up. On the other hand, according to NASA, black holes are born when big stars die. Typically, it is a violent death that involves an intense burst of energy that destroys or pushes away close items. That means it is almost impossible to form two black holes close enough together that will merge during the age of the universe. But pushing them together in densely populated areas, such as the cores of star clusters, is one approach to encourage them to merge. The LIGO-Virgo-Cadra collaboration observed around 85 pairs of black holes colliding since 2015, which allowed scientists to identify gravitational waves that came from them as Albert Einstein theorized. But how do black holes collide? Observations from the LIGO-Virgo-Cadra collaboration also showed that these cosmic collisions happen frequently. As detector sensitivity increases, it is also expected that scientists would be able to catch more of these events on a near-daily basis during the next observation period, starting this year. But what scientists do not know is how these collisions happen. Two factors can bring black holes that are initially extremely far apart together in star clusters, SciTech Daily reports. For starters, mass segregation causes the most massive things to sink to the center of the gravitational potential well. That means any black holes scattered across the cluster will eventually end up at the center, forming an unseen dark core. There are also dynamic interactions, wherein the gravitational impact of neighboring objects can alter the interactions of two black holes in the cluster. These factors might cause the binary to lose orbital energy and drift closer together. These two things that might occur in star clusters can leave traces on the parameters of merging binaries. The geometry of the binary's orbit shortly before it joined is an important characteristic. The orbital configurations can be rather extended or less like the peaceful, sedate circle that the Earth traces about the Sun, and more like the squashed ellipse that Halley's Comet rushes along in its travels in and out of the solar system because star cluster mergers may occur fast. The gravitational wave signal of black holes includes distinct modulations that may be investigated to determine where the two objects collided, especially when they are in such an elongated orbit. So what happens when black holes collide? As per the Black Hole Encyclopedia of Space Telescope Science Institute, black holes merging can become one bigger black hole, but it will be an extremely violent event that even computer simulations could not exactly show it. But scientists know that it would produce tremendous energy and send massive ripples, called gravitational waves, through the space-time fabric of the cosmos. No one has ever witnessed black holes merging yet, although it has been detected many times. There are even galaxies with two supermassive black holes that move dangerously close to each other. Theoretical models suggest that these black holes spiral toward each other until they eventually collide. Gravitational waves have been a fundamental prediction of Einstein's theory of general relativity, and detecting them would provide an understanding of gravity, as well as give new insights into the physics of black holes. Powerful instruments are currently under construction to detect these waves from outer space. So what do you think about the scientists' findings? Do you think one day human can finally travel into a black hole to reveal more mysteries and coming back home safely? Let us know in the comments below. If you also enjoyed this video, please don't forget to support us by liking and hitting the subscribe button and the notification bell so you don't miss our next videos.